Summary of factoring. When factoring, we need to have a plan of what techniques to try and use first, especially because all of our polynomials will be mixed up. We won't have just a sum of squares or just perfect square trinomials that we're factoring all at once. Everything's going to be jumbled up. So here's a flow chart to help you organize the factoring process. I'll have a condensed version of this chart as we go through several examples in this lesson. The very first thing that we do is look for a greatest common factor. In this example, we have a greatest common factor of 2x, so we take that out and we're looking at this polynomial to factor now. The next step we do is count the number of terms. So if we have two terms, we have basically four choices: a sum of squares, a difference of squares, a sum of cubes, or a difference of cubes. So if we have a sum of squares, that looks something like this, and it's prime. A difference of squares, and that's how that factors. A sum or a difference of cubes, and here's the formula for that. If we counted the number of terms and we had 3 terms, we would first check to see if we have a perfect square trinomial. If not, we check to see is the leading coefficient 1. If the leading coefficient is not 1, we do reverse FOIL. Let's say we counted the number of terms and we got 4 terms. Then we would factor by grouping. After we've done all these factoring techniques on whatever polynomial we've been given, the last step is to check to see if it's completely factored. We may have one of our factors that is again factorable. So if it's not completely factored, we would just rerun the flow chart. Run right back through it, go through your choices, and again check to see that it's completely factored. Factor completely here. 4x minus 2. So again, the first thing that we want to do is check for a greatest common factor. And we do have a greatest common factor of 2. After we take that out, we have the binomial 2x minus 1. Now we're looking at trying to factor this. Count the number of terms. It's 2 terms. Is it a sum of squares, difference of squares, or a sum or difference of cubes? No, it doesn't have any exponents. So is it completely factored? Yes. 6x squared minus 19x plus 15. The first thing we do is check for a greatest common factor. For this polynomial, we have no greatest common factor, so we'll count the number of terms. We have 3 terms, so here are our 3 options. First, is it a perfect square trinomial? It's not a perfect square trinomial because 6x squared is not a square, and 15 is not a square. So is the leading coefficient 1? No, the leading coefficient is not 1. So we're going to do reverse FOIL. Okay, so we're going to break up our 6x squared. Let's say that we try 2x and 3x first. With 15, we could break it up as 3 times 5. And I know with this plus, my signs are both going to be the same. And this tells us that it'll be negative. So we'll put a negative and a negative. Let's try checking the middle. We have a negative 10 here, and a negative 9x, and that makes a negative 19x, which is exactly what we want. Alright, is this completely factored? Well, I have no exponents left, so there's no chance of factoring that anymore. So we are finished. 2m squared minus 4m plus 4. Again, the first thing we want to do is take out a greatest common factor. We do have a greatest common factor of 2. When we take that out, we're left with m squared minus 2m plus 2. Now let's see if we can count the number of terms. We have 1, 2, 3 terms. It's not a perfect square trinomial because although m squared is a square, 2 is not a square. Leading coefficient is 1. Yes, since we factored out that GCF, the leading coefficient is 1. So this is the case where we want to find factors of C that add to B. Is there anything that we can multiply together, two numbers that multiply together to be 2 and add together to be -2? No. So that means we are completely factored. All we could do with this polynomial is take out a greatest common factor. We don't say that it is prime because we did at least take out a greatest common factor. Z squared minus 4. The first step, take out a greatest common factor. We don't have one. So next we count the number of terms, and we have 2 terms. So with 2 terms, it could be a sum of squares. A sum would mean that we would have to have a positive. So maybe it's a difference of squares. This is a square, this is a square, and that's my difference sign. So yes, it's a difference of squares. So we're going to factor as z and z in the first spots, 2 and 2 in the second spots, and different signs. Now, is it completely factored? Yes. For one thing, we have no more exponents, so we know we're completely factored. AB squared minus 4a. The first thing we do is check for a greatest common factor. We have an a, and then we're left with a b squared minus 4. Now let's count the number of terms. We have 2 terms, so maybe we have a sum of squares. No, because we have a minus sign. So maybe it's a difference of squares. We have a square, and a difference sign. So yes, this is a difference of squares. So we factor that. And then, is it completely factored? Yes, we have no more exponents, so there's no chance of factoring any further. 3x to the 4th y plus 24xy to the 4th. The first thing we want to do is take out a greatest common factor. We have a 3 in common, we have an x in common, and a y in common. So a 3xy will be taken out of this binomial. That leaves me with an x cubed plus 8y cubed. Now we count the number of terms. 2 terms. So maybe it's a sum of squares. No, because those are not squares. It's not a difference of squares. Again, we don't have a minus, and those are not squares. So it could be a sum or difference of cubes maybe. And we know here it's going to be a sum of cubes. X cubed is a cube, 8y cubed is a cube, and we have the sum sign. So we carry down our greatest common factor, and we know that our sum of cubes is going to factor as a binomial and a trinomial. Then I have an x and a 2y. Square this, and multiply those together, and use our SOAP rule. Same, opposite, and always positive. Now we check, is it completely factored? Well, we can't factor this any further, and we know that the trinomial that results from factoring a sum or difference of cubes is always prime. So we are completely factored here. 12b to the 4th minus 10b cubed plus 2b squared. The first thing we want to do is check for a greatest common factor, and I do have a 2b squared in common. So I'm going to take that out, and I'm left with a 6b squared minus 5b plus 1. Now I want to count the number of terms. I have 3 terms. So is this a perfect square trinomial? It's not, because 6 is not a perfect square. The leading coefficient is not 1. So we're looking at here doing a reverse FOIL method. Let's break up the 6b squared as 2b and 3b. 1 can only be 1 and 1, and our signs are both going to be the same, and this tells us they'll both be negative. Now let's check the middle here. A negative 2b and a negative 3b is negative 5b. So, are we completely factored? We have no exponents here to factor further, and this is just our greatest common factor, so we're finished. 6y squared z minus 24z cubed. The first thing is to check for a greatest common factor. We have a 6 and we have a z common. After we take those out, I have a y squared minus 4z squared. Let's count the number of terms. We have 2 terms here. So, is it a sum of squares? No. Is it a difference of squares? Yes. So we have 2 binomials that we'll break that up with, and it'll be a y plus 2z and a y minus 2z. Now, are we completely factored? Yes. We have no exponents left here to factor out, and our GCF is sitting in front. A cubed plus 8. Let's check for a greatest common factor. There is none here, so we'll count the number of terms. 2 terms. So, is it a sum of squares? No. A cubed is not a square, and 8 is not a square. So it can't be a difference of squares either. It's a sum of cubes. So we are going to factor this as a binomial times a trinomial. This gives me a plus 2, and then an a squared, a 4 here, a 2a in the middle, and of course our signs by the SOAP rule: same, opposite, and always positive. Now from there, is it completely factored? This is completely factored, and that trinomial that results from factoring a sum or difference of cubes is always prime. So we're finished. 5a squared minus 27a minus 18. First, let's check for a greatest common factor. We don't have one, so we count the number of terms. We have 3 terms here. So we check to see first, is it a perfect square trinomial? It's definitely not. The leading coefficient is not 1, so we're going to do a reverse FOIL method. Go ahead and set your parentheses down. Let's try breaking up 5a squared as 5a and a. It's the only way to break that up. And now with our negative 18, maybe we should try, well, we have factors of 1 and 18, 2 and 9, 3 and 6. After that, those factors just reverse. So let's try factors that are closer together, the 3 and the 6. Now I know I have a minus sign here, so let's go ahead and make our signs opposite signs, different signs. Let's check the middle. I have a 30a and a negative 3a makes a 27a, but I need a negative 27a, so I'll make this the positive and this one the negative, and that takes care of my factorization. And are we completely factored? Yes, we have no exponents left in order to have a chance to be factorable. 6m cubed plus 2m squared minus 10m. Let's check first for a greatest common factor, and I have that, a 2m. 2m, and I'm left with 3m squared plus m minus 5. Now I'm going to count the number of terms. I have 3 terms. It's not a perfect square trinomial, and the leading coefficient is not 1. So I'm going to try and factor this with reverse FOIL. We can only break 3m squared up as 3m and m. Let's try a 5, maybe a 5 and a 1. And the minus sign means that we're going to have opposite signs. So I'm not sure if they're in the right place or even if this is going to work, but we'll try it. So we have a negative 15m and a positive 1m does not make 1m. So let's try our only other option here is to put our 5 here and our 1 here. This gives me a negative 3m and a positive 5m, which is 2m, not m. So we've exhausted all of our possibilities. It doesn't factor any further. So it is completely factored. We can't factor that any further, and we just have taken out the greatest common factor. 24x cubed minus 4x squared minus 160x. First, let's check for a greatest common factor. We do have a greatest common factor of 4 for our numbers and x for our variables. So we're going to take out that GCF of 4x. That leaves me with a 6x squared minus x minus 40. Now let's try and factor this. We have 3 terms. It's not a perfect square trinomial, and the leading coefficient is not 1. So we're going to do the reverse FOIL method for this one. Let's break 6x squared up as 2x and 3x. The 40 we could break up as 1 and 40, 2 and 20, 4 and 10, 5 and 8. Let's go ahead and try 5 and 8 since those are factors closer together, and this is a fairly small number, so we want to pick numbers that are closer together. 2 and 3 rather than 6 and 1, 5 and 8 rather than something like 2 and 20. And again, my minus sign tells me that I'm going to have different signs. Now check the middle. This is a 16x and a negative 15x, and that gives me a positive 1x, but I need a negative x. So that means that I'm going to go back and change my signs. We'll make this a negative and this a positive, and that fixes it. Now, after that, are we completely factored? Yes, we have no way of factoring any further. 8b to the 4th plus 24b cubed minus 2b squared minus 6b. The first thing we do is check for a greatest common factor. And we do have a greatest common factor of 2b. So I'm going to take that out. And I have 4b cubed plus 12b squared minus b minus 3. Now let's count the number of terms. I have 4 terms here, so my only option is to factor by grouping. When I do factor by grouping, I'm going to put a square bracket there, and I look for the greatest common factor of my first 2, which is 4b squared. And that leaves me with a b plus 3. Here I'm going to take out a greatest common factor of negative 1, and I'm left with b plus 3. Now, since those binomial factors match, I'm able to go on with my factor by grouping. I have a b plus 3, I have a 4b squared minus 1, and of course my greatest common factor in front. Now, after factor by grouping, are we completely factored? Well, look, here it looks like we may be able to factor this. If we count the number of terms, we have two terms. 4b squared minus 1 is going to be a difference of squares. So here we go. I have a 2b plus 1 and a 2b minus 1. Now, again, is it completely factored? This time, we have completely factored this polynomial. 4x squared minus 12x plus 9. Do we have a greatest common factor? No. Count the number of terms. We have 3 terms, so is it a perfect square trinomial? It could be because we have a perfect square here, we have a perfect square here, and in the middle we just need to check to make sure we can get factors that add up to that middle term. So let's factor this as if it were a perfect square trinomial. This would be a 2x, this would be a 3, and we carry the minus down. Now when we check the middle term, then we have 2x times negative 3 doubled. That gives me 2 times negative 3 is negative 6, times 2 is negative 12, times the x is negative 12x. Exactly what we want. Now, is that completely factored? Yes, we can't factor 2x minus 3 any further. M squared plus 9. First, do we have a greatest common factor? Not this time. We count the number of terms. We have 2 terms. Is it a sum of squares? It definitely is. A square added to a square is a sum of squares. So we know that this polynomial is prime. X cubed minus x squared plus 5x minus 5. The greatest common factor, we don't have one. We count the number of terms, and we have 4 terms. So we're going to factor by grouping. We take out x squared out of the first 2, and a positive 5 out of the last 2. Now I have a greatest common factor of x minus 1, and I'm left with x squared plus 5. Now, are we completely factored? Well, x minus 1 is completely factored. What about x squared plus 5? It's not a sum of squares, definitely not a difference of squares, and definitely not a sum or difference of cubes, so we are completely factored here. H squared minus 5h plus 4. First, checking for a greatest common factor. We don't have one here, so we count the number of terms. We have 3 terms. Is it a perfect square trinomial? It could be because we have an h squared and a positive 4, but remember our middle term will always need to be an even number. So it's not a perfect square trinomial, but the leading coefficient is 1. So what we need to do is find factors of 4 that add up to be negative 5. So we have an h and an h there, 4 and 1, and a positive means we're having the same signs. The minus means that they'll both be minuses. Now let's check the middle term. A negative 1h and a negative 4h makes a negative 5h. Now is it completely factored? Definitely. We have no exponents, so there's no chance of factoring any further. That completes this lesson, so go ahead and try your homework. Keep your factoring diagram with you so that you can follow this flow chart as you do your work. Be sure and let me know if you have any questions on any of the factoring techniques.